Alright, we're on to 5-4, which is multiplying binomials mentally. Now, this section should hopefully be really easy for y'all because we have multiplied binomials before. Okay, and now we're actually going to, hopefully, we've gotten good at it that we can almost just do it mentally. So you're going to see it in just a couple moments. We're going to do it. Also, I'm going to show you another little trick. So we'll go from there. So, because factoring is basically the opposite of polynomial multiplication. It is important that we can quickly multiply binomials. To check to make sure factoring is correct. Okay, and I was showing you that before. Binomials is it has monomial is kind of like one. It could have variables and coefficients or numbers in it, but then you have a plus or a minus, and then you have something another monomial. That's a binomial. Just reminding you. Okay. So we're going to check to make sure. So we need to make sure we are able to multiply binomials mentally so that we can check it really quick and not waste all of our time reworking the problem back out. So you will notice that binomials that only have one variable, variable, have easy to predict products. Okay, so let's remember what we do to factor this out. Now, you might say, Miss Robinson, why didn't you teach us this before? Because the book does not introduce it till now, and I didn't want to confuse you. Also, sometimes you want to learn other ways to do it, and then learn another way, and it can that's simpler. But once you've understood the complex part, the simple part, kind of just helps it. So, okay, so it's called the FOIL method. Some people have brought it up, and this works for multiplying binomials only, not, if you have 3 terms, so polynomials. FOIL, it stands for first, outer, inner, last. So basically, that's saying what order you were to multiply this out. Again, the order does not matter as long as you multiply the first ones, the outer ones, the inner ones, and the last ones at some point in time. So the first ones are the first 2. So here it's the first one, and this is the first one. So you multiply those together to get x squared. Then outer, you take the outer one, so that's this x and the 2, because those are the outermost ones. So that's plus 2x. And then we have the inner ones, which is 5 and x, so that's plus 5x. And then we have 5 times 2, which is 10, and those are both the last terms. And then you simplify, so x squared plus 7x plus 10. Now, again, this is just another way, FOIL. You'll probably hear me say that. But that's not mentally. That was just kind of a review of multiplying it out. But we're going to kind of scroll down here a little bit and kind of tell you how you can do it quicker. And you might notice that I do that. And here's kind of how I do it. So the first term always has, has a variable squared. Okay, the middle term is the middle term's coefficient. Hopefully we know what coefficient is. It's the number in front. Is the sum of the 2 numbers, and so that's saying you see these 2 numbers right here? It's the sum of those. So 5 plus 2 is 7. Oh, look how that shows up right there. And the last is the product, which we know product is the answer to a multiplication problem of the 2 numbers. So what's our 2 numbers? 5 and 2. So that equals 10. So look, we got those exact answers by just doing what we have right here. So I'm going to show another example actually right here, and we're going to do this one mentally. Okay, so we have x minus 1 and x plus 5. Okay, so right here it says the first term always has the variable squared, so x and x, so it's x squared. Okay, so you're doing it in your head, but I'm just writing it down. Okay, and then it says the middle term's coefficients is the sum of the two numbers. So I have a -1 and a +5. So you add those together, and that's a +4. So it's going to be a plus 4x. Obviously, we know it has to be an x. Okay, because you see that. And then the last one is the product. So a -1 times a +5 is a -5. So that's what you would get if you were to factor it all out. So hopefully this is kind of starting, we've learned this already. So this is, gonna be quicker and you're able to do it mentally. Last part. Okay, so a quadratic term refers to a term that has that is second degree. Degree talks about the exponents, right? Okay. So therefore, the degree of the variables, the exponents of the variables. There you go. And it says a linear term refers to a term that has first degree. So you see how this is x, that's to the first degree, okay? And a constant term refers to a term that has no variable factor, which in this case would be -5. So we have an example over here. So we need to I want you to identify what is the quadratic term. So it has to have a second degree, which is the 2x squared. So that's in this problem, that's my 2x squared. My linear term, it's the one that has first degree, which we actually don't put exponent to the 1, so that's why it's 7x, because we have that imaginary 1 right there. And our constant term has no variables, so that one is going to be 3. So there you go. Got some new vocabulary in here, and we also are just kind of reviewing, but trying to hopefully do it quicker. Okay, bye.